Welcome back to History of Simple Things. Today's topic comes from one of our viewers, Lennox Mundell 9783. Thanks for the suggestion. You asked, why don't windshields blow out facing all that wind pressure? If you've ever been cruising down the highway and looked at the massive sheet of glass right in front of you, you may have wondered how it manages to stay in place. After all, at highway speeds, your car is constantly pushing through powerful winds, and the windshield seems to take the full force of that air. So why doesn't it simply pop out or shatter from all that pressure? Stick around as we uncover the clever engineering that keeps your windshield securely in place, right here, on History of Simple Things. The earliest automobiles didn't even have windshields. Drivers simply wore goggles to shield their eyes from dust, insects, and flying debris. As cars became faster in the early 1900s, manufacturers began installing glass windshields. Unfortunately, these early panes were made from ordinary glass, which shattered into dangerous sharp pieces during accidents. Everything changed in 1903 when French chemist Edouard Benedictus accidentally discovered laminated safety glass after dropping a glass flask that had been coated with a thin layer of cellulose nitrate. Instead of shattering into fragments, the glass cracked while staying largely intact. Decades later, this invention became the foundation of modern automotive windshields. Today, laminated safety glass is required in nearly every passenger vehicle because it dramatically improves both safety and durability. At highway speeds, your car certainly experiences strong airflow, but the pressure isn't concentrated on the windshield the way many people imagine. As air flows over the vehicle, it naturally splits and travels around the car's shape. Modern vehicles are carefully designed inside wind tunnels to reduce drag and smoothly guide air over the roof and around the sides. Rather than acting like a flat wall resisting the entire force of the wind, the windshield is tilted at an angle. This slope design helps the air glide upward instead of slamming directly into the glass. The smoother the airflow, the less force builds up on any one area. Even at speeds of around 70 miles per hour, the pressure is well within the limits engineers designed for. In fact, the bumps and vibrations from rough roads often create more stress over time than the steady force of the wind itself. One of the biggest misconceptions is that a windshield is simply a thick piece of glass. In reality, it's a laminated sandwich made from 3 layers. 2 sheets of specially treated glass surround a durable plastic layer called polyvinyl butyrol, or PVB. If something strikes the windshield, the glass may crack, but the plastic layer keeps the pieces bonded together. This is why a cracked windshield usually develops spiderweb-like patterns instead of exploding into the driver's face. This layered construction also makes the windshield surprisingly resistant to bending. Instead of flexing like a thin window pane, the entire sandwich shares the load across its surface. Many people assume the windshield is held in place with rubber seals. While older vehicles relied more heavily on rubber gaskets, modern cars use incredibly strong polyurethane adhesive. During assembly, a thick bead of this adhesive is applied around the windshield frame. Once cured, it forms an exceptionally strong bond between the glass and the car's body. This adhesive isn't there only to keep out rain. It also helps make the windshield a structural part of the vehicle. In many modern cars, the windshield contributes significantly to the roof's strength during a rollover and helps the passenger side airbag deploy correctly by providing a rigid surface for the airbag to push against. The windshield doesn't fight the wind by itself. It's supported by the surrounding steel or aluminum frame, known as the windshield opening or frame. When wind pushes against the glass, the force spreads into this rigid structure instead of remaining concentrated on the glass alone. Think of it like a drumhead stretched across a sturdy frame. The material itself isn't carrying all the force, the frame distributes much of the load. Engineers use computer simulations and extensive crash testing to ensure this entire assembly can handle years of driving, temperature changes, vibrations, and severe weather. That's also why improper windshield replacement can be dangerous. If the wrong adhesive is used or the installation isn't done correctly, the windshield may not provide the structural support it was designed for during a collision. Can wind ever blow out a windshield? Under normal driving conditions, almost never. Even hurricane-force winds are generally not enough to blow out a properly installed, undamaged windshield while the vehicle is intact. Most windshield failures happen for completely different reasons. A rock may create a chip that gradually spreads into a crack. Rust around the windshield frame can weaken the mounting surface. Poor installation after a replacement can reduce the strength of the adhesive. In severe crashes, the vehicle's body can deform enough to force the windshield out. So if you ever see a windshield detached from a car, it almost certainly wasn't caused by ordinary driving speed alone. So, the next time you're cruising down the highway, remember that your windshield is doing much more than blocking bugs and rain. Its angled shape helps guide the airflow. Its laminated construction keeps it from shattering. Its powerful adhesive bonds it firmly to the vehicle, and the surrounding frame shares the forces generated during driving. Together, these features create a system that's engineered to withstand far more than everyday wind pressure. It's one of those everyday parts we rarely think about, yet it's quietly protecting us every mile of the journey. And like many simple things, the windshield turns out to be far more sophisticated than it first appears. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution.
Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.